Hey guys, this is Miss Pasenko. We are doing some more similarities and word problems today. So the objectives are you guys will be able to use similarities to find lengths and angle measures and to solve for missing variables. You guys will use scale factors to find missing measures, and then you will be able to draw pictures and use proportions to solve word problems. It's okay if you're not a great artist, because neither am I. We totally love stick figures and, just drawing kind of lines to signify a height or a length. The biggest thing that I want you guys to remember here is, and from, yesterday's and the week before's lesson, is that similar polygons have all the same angle measures. So if you have a triangle and you have this triangle here, let me write. You have this triangle here, and then you have this triangle here. Their angle measures can all be congruent to, the corresponding angle in the other triangle, but clearly your lengths here, so say this would be 1, 2, and 3, this could be like 3, 6, and 9. So all the same angles, like the corresponding angles have the corresponding, or the angles have a corresponding angle in the other figure that it is congruent to, but the side lengths are different. The corresponding lengths must be proportional. So if we were to look to do this here, and we did, 1 over 3, and then 2 over 6, and 3 over 9, this would reduce to 1 over 3, this would reduce to 1 over 3. So all of the scale factors are 1 over 3. So that means that these polygons would be, or these triangles rather, would be similar. So they can have all the same angles, but their lengths will be different in order to be similar. Okay, so that being said, we are going to take that angle info and use it here. So for number 1, okay, it's telling me that these triangles are similar, okay? So that being said, U is 39, they give us that here, which means in my other triangle, so U is in the middle, L is in the middle here, my other triangle, L would also be 39. It's asking us to find V, so V and M are the same, okay? So if this angle is 39 here, and N, they told us, was 58, that also means that W is 58 because they're corresponding angles here. We have W here, N here. So then I can just do some simple math. 58 plus 39 is 97, and we know that triangles add up to 180. So we do 180 minus 97, and we would get angle V is equal to 83 degrees. Then I'm going to erase this stuff here so that we can get a little clearer picture. It is asking us to find LN. Whoops. So relating to the other triangle, okay, LN is here. Or that's not LN, that's LM. Hold on. LN is here, so that means LN is corresponding with UW. Which would be here. And they give us that length already. But we need to figure out what would LN be. So we're going to have to set up a proportion. The other corresponding side that they give us is LM. Whoops. I didn't want that color. LM, which is corresponding to UV, which is here. So in looking at that, you could probably say, oh, both those sides are the same, so my LN is going to be 45, but it's not always going to work out nice like that, so you might as well just get used to doing the proportion. So I'm going to do small triangle to large triangle. So the small triangle for the green side is 18, the large is 45. The small triangle for the yellow side is 18, and the large we don't know what it is. So again, if I just cross multiply, this is going to be 18x equals 45 times 18. If I divide both sides by 18, they cancel and I get x equals 45. So that means that NL is equal to 45. Now it's not always going to work out nice like that. I should have chose a different question, but that's okay. Okay, so number 2, we are trying to find a side length and we are trying to find an angle length. Or angle measure, sorry. So the easiest one here would be to do the angle because technically you have 2 triangles and like you have the small triangle and then the big triangle that surrounds that small triangle. So if this top angle is 92 and the corner angle is 41, they already told us that these 2 angles or these 2 triangles are similar. So that means this angle would have to be 41. And then this angle would be the same as this angle here. So 92 plus 41 is 138, and 180 minus 138 is 47 degrees. So angle D equals 47 degrees. And that is that's found just by doing some simple subtraction there. Now we want to do the corresponding sides here so that we could find our question mark. Okay, so 16 and the question mark are partners, and then 8 and 20 are partners. So this one is going to be a little easier with the setup, or it's going to make more sense when we do the proportion because we're going to get a different answer. Okay, so again, I'm just going to do small to large for the proportion. You can do large to small, that's fine. So I have 16 that I'm going to do the yellow ones first. It does not matter which one you start with. So I have 16 over x and then 8 over 20. You're going to cross multiply. You get 8x equals 320. And then if I divide both sides by 8, I get x equals 4. Oh, 40. I'm like, that doesn't make sense. That's way too small. So the question mark is 40, is the length of 40. If there is like a missing measure or there's a question mark, you need to add that in as an X, okay? All right, given 2 similar figures, find the scale factor and the 2 missing measures. So first of all, they give us, I'm going to line up my sides with the corresponding sides. So these are put in the same direction for a reason. They didn't give us a similarity statement. So 9 and 6 go together. 12 and y go together. And then x and 10. So to find the scale factor, the only one that has, you know, the 2 numbers there would be this and this. So I'm just going to use that as my scale factor. 6 over 9 can simplify down to 2 over 3 if I divide the top and the bottom by 3. So I'm going to use that scale factor there to find the missing measures. And I need to set up a proportion. So I'm going to start with 2 over 3. That's the small to the large. This one's the small one. This one's the large one. And I'm going to find x first. So on the small one, my side that is also x would be 10, and then x is x. So when we cross multiply, 2 times x is 2x, 10 times 3 is 30, and then you divide both sides by 2 and get x equals 15. We're going to set it up the same way to find y. You use that scale factor that we found first. The small one is y, the big one is 12. 3 times y is 3y, 2 times 12 is 36. Divide both sides. Oh wait, did I screw something up? Oh no, 2 times 12 is not 36. Hello. 2 times 12 is 24. And then divide both sides by 3, and you get y equals 8. I want you guys to go ahead and try the next one, and then I will do the answer for you, obviously. So I'm going to highlight the sides that go together, and they are written in this way for a reason, so that they didn't have to write a similarity statement. C goes with 4, and JK goes with NP. Okay, so again, first we want to find the scale factor. You just need to find a side, or the two sides, the two corresponding sides that both have a number. So we have, whoops, I don't want to do that. We have JK here and NP both have a number, so that's how we're going to find our scale factor. 6 over 9. That would reduce to 2 over 3 as well. Okay, cool. So I have 3 different variables to find here. So I'm going to use my scale factor. I'm going to just start with A because that's easiest. So A is here. A goes with the 2. This one's the small, this one's the large. I'm going small to large for my ratio. A, and then 15 is the large side. So 2 times 15 is 30. 3 times A is 3A. So A would end up equaling 10. That is not a good color for down there. A equals 10. Then I can find B. So B is this green side. So again, I'm going to use my scale factor, 2 over 3. The small one is 8. The large side is B. 2 times B is 2B. 8 times 3 is 24. And then I would divide both sides by 2 to get 12 for B. Then the last one is C. You're still going to use that same scale factor. That scale factor doesn't change. That is like your buddy. You want to use that in every single problem. I told that to you guys in the first lesson that we did on this chapter. So the small side is 4. The big side is C. 2 times C is 2C. 3 times 4 is 12. Divide both sides by 2. You get C equals 6. Again, if you guys need to pause this at any time, please go ahead and do that. In your notes, if you printed these out, please make sure to add in that highlighted part that triangle CDE is similar to triangle CUV. If you look at that picture without having the similarity statement, you're not going to get the right answer. So I'm going to go ahead and highlight my sides that are corresponding. So EC here goes with VC. So this one here. See how that happens? Then we also have DC. So DC is here, which goes with UC. So if you were just looking at that without the similarity statement, you would probably get it wrong because you would assume that the 98 and the 60 are corresponding when they are, in fact, not. Okay, so to find X, we're just going to set up a proportion. The green ones go together. So 6x minus 2 over 98 equals, make sure, so this is one triangle. I use 6x minus 2 first, so I need to use 60 first in the second fraction. You're going to cross multiply. You get, so with these big numbers here, leave that 84 out in front and then multiply the 98 by the 60. Because chances are you're going to be able to divide both sides by that number in front. And you would end up getting 6x minus 2 equals 70. And then you can add 2 to both sides. 6x equals 72. And then divide both sides by 6 and get x equals 12. So x equals 12 in this one. Now the next one, I realize it kind of looks a little weird here, but we are not going to teach you this theorem here, but there's something called the side splitter theorem, which basically means that the corresponding sides, so like this side and this side go together, and then this side and this, sorry, let me rephrase that. This is one whole figure, and then this is another whole figure. Okay, so then, that being said, this side here is corresponding to this side, and then this side here is corresponding to this side. So you would just set it up as a normal proportion. You would just do your x over 28 equals 8 over 16, and you just cross multiply and solve. 16x equals 28 times 8 is 224, and then divide both sides by 16, and you get x equals 14. Then for the last one, so this is kind of similar. So we have, let me do my corresponding sides here. So 3x goes with 63, 55 goes with 99. So set it up under proportion. Does not matter how you do it or which comes first. So it should look like this. You're doing, the small triangle to the large one. Then we're going to cross multiply. I realize I don't have a lot of room on here, so sorry for that. I'm going to do 99 parentheses 3x plus 5 equals 63 times 55 is 3,465. And again, chances are if you leave that 99 out front, you'll be able to divide both sides by that number and work with smaller numbers. So 3465 divided by 99 is 35. And then you would subtract 5 from both sides, and you would get 3x equals 30. Divide both sides by 3, you get x equals 10. I just wanted to revisit these. You don't really have to remember them or memorize them. If, like I said, if we do have something like this on a test, we will give you, or I will give you these at least. So you have the angle-angle similarity postulate. If two angles of one triangle are congruent to two angles in another triangle, then the triangles are similar. So if you were given, two pictures, and we did not, or two diagrams like this, and we did not tell you that they are similar, you could use this postulate to help you decide that they are similar. Same with the side-side-side similarity theorem. If the lengths of the corresponding sides of two triangles are proportional, then the two triangles are similar. You guys know that already. That should be something that, is easily remembered, because you have to find the proportions of all the sides to see if they're similar. Then the last one, side-angle-side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So if you have two figures and you have a side that's proportional to another side, you have one congruent angle, and then another side that's proportionate, you can say that those two triangles are similar. Okay, so I'm going to do a couple questions here. I don't want to make this video super long. I want to get through all of them, but I might make a second video for that. So I'm going to do like the first 4, and then I will probably end up doing another video for the other ones so that you guys can try those on your own. Okay, so a building casts a shadow that is 50 feet long. A flagpole that is 40 feet high casts a shadow that is 6 feet long. How tall is the building to the nearest foot? Okay, so this is, again, a proportion. For these types of problems, we are assuming that the triangles are similar. That is the only way to be able to solve these if they're similar triangles. So even if it doesn't say they're similar, we want to assume that they're similar. Okay? So I'm going to set it up as this is the building, this is the shadow. Building over the shadow. So that being said, for the first one, the the flagpole is 40 feet, the shadow of the flagpole is 60. The building, we don't know what it is, the shadow for that is 50. So you're just going to go ahead and cross multiply. 6 times x is 6x, 40 times 50 is 2,000. and then you divide both sides by 6. So this is not a pretty number by any means, so I'm just going to round it to 2 decimal places and make sure that you have your units on there. For number 2, Erin, who is 160 meters tall, casts a shadow that is 1.25 meters long. Her shadow extends to the end of the tree shadow. So this is an important word here. That means that this whole thing here is the tree shadow. What is the height of the tree? So we would have to add these 2 lengths together to get the height or the length of the tree shadow, which is 6 meters. So again, we're going to set it up as the building, or the height rather, height over the shadow. And you could do shadow over height if you want. So the height of the girl is 1.6, her shadow is 1.25. The height of the tree, we do not know what the height of the tree is, so that is our x. The shadow length is 6, and then you're just going to go ahead and cross multiply. 1.25 times x is 1.25x, and then that equals 1.6 times 6, which is 9.6. And then you would divide both sides by 1.25, and you would get x equals 7.68 meters. Again, we're working with units. You want to put that unit down. A tree 24 feet tall casts a shadow 12 feet long. Brad is 6 feet tall. How long is Brad's shadow? So I suck at drawing, so there's my tree. The tree is 24 feet tall. It casts a shadow 12 feet long. Brad is 6 feet tall, and we don't know what his shadow is, so that's going to be our x. Again, you can set it up shadow over height or height over shadow. I'm going to do height over shadow. So for the tree, I have 24 over 12. For Brad, I have 6 over x. Cross multiply. 24x equals 72. 12 times 6 is 72. You divide both sides by 24, and you get x equals 3 feet. A tower casts a shadow 7 meters long. So again, you can draw a picture. It doesn't have to be pretty. I'm not going to grade you on that. So the shadow is 7 meters. A vertical stick. Whoops. I'm just going to draw a line. Vertical stick is 1.2 meters high, and it casts a shadow that's 0.6 meters long. So we are trying to find out what the height of the tower is. Again, so height over shadow equals height over shadow. Cross multiply, so you get 0.6x equals 1.2 times 7, which is 8.4. Divide both sides by 0.6, and you get x equals 14 meters. Okay, if you printed the notes out, I would prefer that you go ahead and try these next problems. There are a lot, but this needs to be done. The practice needs to be done. So I'm going to go ahead and just do the rest of these problems. If you are doing this at home, please make sure to pause it and try these 2 at a time, so that you aren't just copying down the answers and learning it that way, because that's not how you can learn. All right. Okay, so giraffe is 18 feet tall. I'm not drawing a giraffe for you guys, and casts a shadow of 12 feet. Miranda casts a shadow of 4 feet. How tall is Miranda? So 18 over 12 equals x over 4. Again, you can use a different variable than x. I don't care what you use. Just make sure that you're using some kind of variable. 18 times 4 is 72. If I divide both sides by 12, I get 6 feet. Mr. Kirkton is trying to figure out how tall the school is. If he is 6 feet tall and his shadow is 4 feet long, how tall is the building if the shadow is 30 feet? Okay, so again, height over shadow, height over shadow. 4 times x is 4x, 6 times 30 is 180. If I divide both sides by 4, I get x equals 45 feet. Again, if you need to pause this, go ahead and do that. I'm going to run through these quick, so if I'm going too fast, just pause it. Recipe for spaghetti sauce requires 5 bottles of ketchup to make 2 gallons of sauce. So we're going to do bottles to sauce. So 5 bottles to make 2 I don't want sauce, I want gallons here, sorry. Gallons. 5 bottles of ketchup to make 2 gallons of sauce. How many bottles of ketchup are needed to make 12 gallons of sauce? 2 times x is 2x. 5 times 12 is 60. Divide both sides by 2, you get x equals 30. And you can say 30 bottles, I would say. 3 apples cost $1.50. How much would 5 apples cost? So we want number of apples over the cost. So 3 apples, $1.50. 5 apples would cost what? So 3 times x is 3x. 5 times $1.50 is 7.5 or 7.50. Divide both sides by 3 and you get x equals $2.50. Make sure you have the units there. Totsaken, enlarge the size of a photo to a height of 18 inches. So I'm going to draw a picture here because these ones are the ones that trick me up. So what is the new width if it was originally 2 inches tall and 1 inch wide? Okay, so again, you can do height over width here. So the original height was 2, the width was 1. The new height is 18. We don't know what the width is. So again, cross multiply. 2 times x is 2x. 1 times 18 is 18. Divide both sides by 2. You get 9 inches for the width. A frame is 9 inches wide and 6 inches tall. If it is to be reduced to a width of 3 inches, then how tall will it be? Okay, so again, doesn't matter how you set it up. We can do width over height equals width over height. 9 times x is 9x, 6 times 3 is 18. Divide both sides by 9 and you get x equals 2 inches for the height. When a Ferris wheel casts a 20-meter shadow, this is 20 meters, and a man 1.8 meters tall casts a 2.4 meter shadow, how tall is the Ferris wheel? So again, height over shadow equals height over shadow. Cross multiply, so we have 2.4x equals 36. Divide both sides by 2.4 and you get x equals 15 meters. So the Ferris wheel is 15 meters tall. Number 12 is a little tricky. So a rectangle has a length of 4 feet and the perimeter is 14 feet. You got to remember that perimeter is adding up all the sides. So if one length is 4, the other length has to be 4. 4 plus 4 is 8. So that means 14 minus 8 is 6. That means both these sides have to be 3 here. What is the perimeter of a rectangle with 9 feet? Perimeter is what we don't know. The width is 9 feet. Or that's not the width, sorry, I wrote it in the wrong spot. This is 9 feet. I don't have to figure out the length here because that is what I had to do here. They gave me the length and they gave me the width. So I would have to either find the length or the width in one of those two rectangles. And because this one gave us the 14 feet already, it's easier to find the width in this one here. Because you can't do like length and width. You couldn't do, 4 over 14 equals 9 over x, because these two are not the same thing. They need to be in the same spot. So I have 3 over 14 equals 9 over x. Cross multiply, so you get 3x equals 126. And then divide both sides by 3, you get x equals 14 feet. So that's not right. X equals 42 feet. My bad. Looking at the other problem. Okay, Chris wants to reduce a triangular pattern with the sides 16, 16, and 20 centimeters. If the longest side of a new pattern is to be 15, so that would go in the spot of the 20. Okay, that means that this triangle has to have, these two sides here have to be the same length. Okay, so we are trying to figure out what these sides are. We don't need to put in 2 x's, we could just put in 1 to solve this problem. Or you could do both x's and it doesn't matter what side you do. So I'm going to do this side, and then I'm going to do this side and this side. So I'm going to do the small triangle to the big triangle to the smaller triangle. So I do 20 over 15 equals 16 over x. So when you cross multiply, you get 20x equals 240. And then divide both sides by 20, and you get x equals 12 centimeters. So both sides of this triangle, the new reduced triangle, would be 12 centimeters. You only have to do that once. Okay, Jacob bought 3 bulbs of elephant garlic for $5. How many bulbs could he buy if he has $12 to spend? So I did bulbs over how much it cost. So 3 bulbs, $5. How many bulbs for $12? 5 times x is 5x, 3 times 12 is 36. When you divide this out here, you get x equals 7.2. You cannot have 0.2 bulbs, so you want to round that back down and get 7 bulbs for $12. So you'd probably have like a little bit of money left over, a couple cents. Okay. Make sure to do your homework. I believe it's only 5 questions or so. It shouldn't take you that long. If you have any questions, as always, send me an email or, send me an email. Have a great day, guys.